Welcome to video 2 of Module 3. We're looking at a more general form of the exponential equation, where y is equal to a times b to the power of x. In our previous example, or video, we were looking specifically at the equation y is equal to b to the power of x, and therefore a was equal to 1. Adding an initial value of a allows us to have starting values other than equal to 1. When I mention a starting value or initial value, what I mean is the value of y when x is equal to 0. So if we look at this more general equation for the exponential equation, y is equal to a times b to the power of x. So when x is equal to 0, so initially at, say, time 0, if it's a problem in terms of time, we have y is equal to a times b to the power of 0, and b to the power of 0 is just 1. Therefore, it has an initial value of a. And in our previous two examples that we graphed, at time 0, we had an initial value a is equal to 1. Before we look at any other exponential equations or graphs, I want to take a few minutes to practice with your calculator and also look at practicing rounding your final answers based on 3 significant figures. Example 1 has 5 to the power of 2, so locate the exponent button on your calculator and we're going to round this to 3 significant figures. 5 squared is 25, but to 3 sig figs it's equal to 25.0. You can also use negative exponents, so 5 to the power of negative 0.5, which is 0.447 rounded to 3 sig figs. 0.5 to the power of 8 is 0.00391. 0.5 to the power of negative 8 is 256. Notice examples 1 through 4 all have an a value equal to 1, whereas example number 5 has an a value of 3. And when we do 3 times 2 to the power of 3, you end up getting 24.0. On your calculator, you can either use brackets, or you can actually use 3 and then multiply it by 2 to the power of 3, as long as your calculator is non-direct entry and evaluates using BEDMAS. We're going to examine the next 2 sets of data within the table and determine whether or not the data is linear or nonlinear without graphing. Okay, in order to do so, we're going to compare the first differences of each of the data sets. In order to use the first differences method, we must first confirm that the intervals between the x values are equal. And we're able to do so by looking, so between each point, we are adding one value to the x value. And since that difference is constant, we're able to examine the differences between the y values to determine whether or not it's linear or nonlinear. If the relationship is linear, we will have a constant difference between the y values. So to calculate this, we look at, so 5 minus 2 is equal to 3, 8 minus 5 is equal to 3, and we can see that we increase by 3 from one y value to the following. And since that relationship is constant, since it's a constant difference, we know that the table above is linear. Anytime the difference between subsequent y values is equal, this means we have a linear relationship. In the second example, we again confirm that there's equal spacing between each of the x values, and we can see that we are increasing by 1 at each x value. Now calculating the y value differences, we see that we have plus 4, then we're adding 12. And even from just examining the first two differences, we can see right away that the relationship is nonlinear since we do not have equal increases in the values of y. We know this relationship is nonlinear because the differences are not equal, but it's actually an exponential equation because we have a constant multiplier in the differences. So going from the first difference to the second, we multiply by 3, and then we multiply by 3 again. So to get from one value to the next, we are multiplying by 3. Therefore, it's an exponential equation. We know the relationship is exponential because we multiply by the same number to get to the next value. Okay, well done. So now we can determine the difference between a linear and nonlinear relationship given a table of values. There are several questions within the homework that's posted on D2L that allow you to compare linear and exponential data sets. So make sure you give those a try and let us know if you have any questions.